Here is grade 7, module 11, lesson 4. Our I can statement is I can solve multi-step surface area and volume problems. So we're kind of taking what we've learned so far, putting it together and just adding different steps. So be really careful with these directions on this problem. You can solve multi-step problems involving surface area and volume by deriving the values of the variables in one equation to use in the other. So on these problems, they might give you the actual answer. Like for here, it gives us the volume, and we need to find the surface area. So here we have the volume is 126 centimeters cubed, and we're trying to, we need to figure out the, you have the length, we need to figure out the width, and then we have the height, question mark, and we know our volume is 126 centimeters cubed. So we first need to use the volume formula for a rectangular prism to find the unknown length of the rectangular prism. So we know that we have volume equals length times width times height, or well, they can be interchangeable, commutative property. So sorry, width, length, and then height. And we have our 126, so we're plugging that in for our volume, equals L times 3 times 7. We're going to multiply our 3 times 7 here. And that means we're going to end up dividing both sides by 21, which is what we're doing here. And what you do to one side of your problem, you always do to the other. And then we have 21 going into 126, which means our length is 6 centimeters. So now that we have our length, our width, and our height, we're able to find surface area. So just to refresh, your surface area is that wrapping paper. So imagine you took wrapping paper and you wrapped it perfectly around this box. You would have your two bases, and then, which is right here, and then you would have your sides. So we have 1, 2. Oh wait, this is in a cube, so we're going to have two different ones. So we're going to have our front, and then our back. Okay, so you'd have your front and your back. I'll try and visualize this for you here. And then our side. So if it were a cube, your sides would all be the same, but this one isn't, so we're going to have to do another color here. And we have our sides here. And then we got to add them all together. So we're going to take our sides and our base and add that with our front and back, and we end up with 162 centimeters squared. And squared, you ask? I thought we were moving on to volume. Squared is area, okay? We're doing length times width, okay? We're not involving that height. We're finding area, so think 2D. You're just taking that wrapping paper, laying it flat, so there's no height to it. It's just that flat piece. Okay, so that is finding our missing variable. So here we have an ice cube tray that holds 12 ice cubes. If the total volume of the ice in the tray is 12 inches cubed, what is the total surface area of the ice cubes? So when I first read this, there's a lot going on here. So I thought, let's draw a picture, and then we're going to write out everything that we know. So we know that we have 12 cubes, and we have a volume of 12 inches cubed. So we're going to use our volume formula because we first need to figure out our length, our width, and our height. So let's see, volume equals length times width times height. And we know that that's 12 inches cubed. And then our length, we don't know what our length is. So let's use some variables here. We're going to use x and x and x. So with the way I drew this out, our length is going to be, how many x's here? 1, 2, 3, 4, 5, 6 times x. And then our width is 2 x's. And then our height is 1x. So we have 12 equals 12x cubed. We'll divide both sides by 12. 1 equals x cubed. So x equals 1, because 1 times 1 times 1 will give you 1. Okay, so now we know that x equals 1. We gotta substitute these back in here to find the surface area of the ice cube, so all of them. So not just one surface area, but all of them. So surface area, we're gonna find, let's see, so now this is 1 by 1 by 1. So surface area, I guess we could do this whole shape here. So surface area would be, pause your video, what do you think? 1 times 1. Actually, you could do each cube too. Different ways to attack this. So what is the surface area of 1 cube? So you'd have 1 times 1 in the front. So this is 1. This is 1. The bottom is 1. Let's actually rewrite that. That's getting kind of messy. 1 cube. So you'd have a surface area on the front, 1 times 1. All of these would be 1 times 1. And how many faces are in a cube? 6. So 6 times 1 would give me 6 inches squared. Okay, so 1 cube is what we figured out here. And how many cubes are there? There's going to be 12. So surface area equals 6 times the 12 cubes. So the total surface area is going to be 72 inches squared. Okay, 72 inches squared. So a couple different ways you could have done that. You could have found the area of the whole object, knowing that all of these x's are 1, and done this like as a front face, and that would have been the same on the back, and then added up like the sides, and then done the top. Or you could have done it like we did, find the area of 1 little cube, and then multiply that by the 12 cubes that we know that are in the ice cube tray.